Hello, everyone. This is Belinda Carr, and you're listening to my podcast on building science, products, and technology. As we know, the construction industry is ripe for automation and disruption. It has been reliant on manual labor and outdated tech for far too long, which has led to lagging productivity. Every week, I chat with a company that is exploring ways to tackle these issues. Today, I'm speaking with Mike Pivac, CEO of Fastbrick Robotics in Australia. Thanks for joining us, Mike.
Great to be with you, Belinda.
So I've been following your work on the Hadrian bricklaying robot for a couple of years. So I'm pretty excited to learn more about how it works and how you develop the technology. I also told the YouTube community that I was going to be speaking with you, and they sent in some very, very interesting questions. So I'll integrate them into our conversation.
Okay.
So let's start at the beginning. So Fastbrick Robotics seems to be one of those businesses that's a labor of love. You've been working on it for a long time. So you're one of those companies that identified this problem of heavily relying manual labor very early on. So when did you actually start with the idea of a bricklaying robot?
Well, the technology development, the stabilization tech that sits behind the machine started a few years before it was identified that a good place to apply that technology was in a robot that could, lay a brick or a block and build a structure from a 3D CAD file. And what tipped that off was we had as you know, construction is a very cyclical industry. Back in 2005, we had quite a building boom happening in Australia. And every time that happens, obviously, tradespeople become hard to get and very expensive. And bricklayers back in 2005 were becoming more expensive. And then it was proposed that, somebody, try to automate the laying of a brick. And that sort of message crept around. And my cousin, Mark Pivac, who's our Chief Technology Officer and my co-founder of FBR, he sort of put his hand up and said, well, look, I think I could build a machine that could do that. And he was able to gather together some seed funding from a couple of very large organisations in Australia and also tapped into the Australian Federal Grants program, which is really quite generous for startups. It's got a little bit worse over years, but back then it was very, very attractive. And then consequently, he built the first Hadrian 105 prototype, which he built on an excavator base. So he bought a Caterpillar 325 excavator and he sort of stripped it down and he built this new boom and he put all this automation stuff on the back of it. And on the day that they were presenting a new information memorandum to some investors was the day that the world woke up to the global financial crisis. And then consequently, this project got put into hibernation, just like, that's it. Let's just shelve it and see what happens. Nearly 6 years later, that was when Mark and I sort of got together and said, well, let's have another go at this. And, we funded it ourselves there for quite some time.
So your excavator machine was in storage for about 6 years?
Yeah, it was. It was just taking up factory space. And Mark said to me, look, come and have a look at this. Let's see what we can do with it. Otherwise, I've got to sell it for scrap. And he actually got a quote for how much he would get for it for scrap. Right? That's how close it went to going in the rubbish bin. Anyway, we sort of put a bit of a plan together, and we said, well, if we can spend the next 12 or 18 months, pumping some money in and getting a lot of. We had a lot of university graduates working with us on weekends and stuff, and we would pay them when we could, and only when we could. And these young fellows were just so enthusiastic, young mechatronics engineers, and they had a real live, robot to work with, which was exciting for them. Some of them still work for us today, which is a great story. But, we're able to get that machine to basically put 3 bricks on the ground in the right spot, 25 meters away.
Oh,
and
wow.
From that point on, we went, well, okay, if we can put 3 bricks through that machine, we can put 3,000 bricks through that machine. So we were then able to, raise the first real sort of bunch of money to get the project up and away. And that was in late 2015. We actually listed the company and raised our first, $6 million and were able to get the project well underway. Since then, we've produced, two Hadrian 109 machines, which one of them you can see in the background behind me there, which are both working in the Perth construction market now. And we have the new Hadrian 110 machine under assembly as we speak. And that machine has a much larger capability, i.e. it's much faster and has a longer reach, but more importantly, it will deliver a much more, a stronger economic case, which is really important when you're delivering, solutions to the construction industry. And I know you understand this well, but, you've got to be better, cheaper, faster. And, if you can't be those things, then your adoption in the marketplace is going to be very low. Yeah. So we've focused ourselves on ensuring that we can bring a machine to market that the industry wants, needs, and will be prepared to pay for. But on the journey, really significantly, we focused on safety and waste reduction as two really key elements of our machine development and our overall program as we sort of moved along the pathway and along the journey, along with obviously making the machines fast and and accurate and all those sorts of things. But safety and waste in the construction industry are two very, very important subjects. We haven't been able to make a lot of ground on those two things over the last sort of 5,000 years. So it's important that we captured as much as we could in improving site safety, and mostly that's around just eliminating the need for humans as much as possible. We still have what we call people in the zone. So a PIS guy will work with the machine and he will sort of walk around the site and, he might place brick ties, or he might put some insulation in between some cavities and bits and pieces. He might correct a brick that might be a little bit out of alignment or something like that. But he doesn't need to be doing anything dangerous. Yeah. Is the goal, right? And obviously the machine operator sits in an air-conditioned cab and he runs the machine with a tablet. So no lifting heavy things, no working from heights, no repetitious, injuries.
Dropping bricks or anything. Yeah.
Yeah. The construction industry has a terrible safety statistics every year. So they really do. And then of course, construction on the waste front. Unfortunately, it does. Construction just generates a lot of waste, and anything that you can do to sort of improve on that.
So let's step back a little bit. I'm sorry. Yeah. Let's step back a little bit. So you've talked about a lot of things. In the beginning, you talked about the funding, and there was, and one of the questions we got from our community was the amount of money that went into building a business like this. You briefly mentioned that you listed your company on the market. Was that different than what you see companies do here in the States? Did it work differently? Does it work differently in Australia?
Look, there was basically no venture capital capabilities in Australia back in, sort of 2012. It was really not happening here. Whereas we see a lot of, VC funds and activity in the US, it's an entirely different funding environment. Companies just don't list in the US, and well, you can't anyway. You have a different set of listing rules there. But occasionally in Australia, the sort of rules relaxed where you can do what they term as a reverse takeover, where you can list by utilising the shell of a company, a former company that perhaps didn't quite get to where they wanted to be. And we adopted one of those sort of shell companies and then did a reverse listing onto the ASX, and that allowed us then to sort of start raising money that way. But it's a different model to what you see anybody else doing. There's only sort of very short windows of opportunity for that in Australia. It sort of comes around maybe once every 5 to 10 years, and it just sort of coincided where we were like at the point where we really needed to raise money, or we were going to have to put this thing into the scrap heap. So it worked for us. I'm not saying it's ideal or perfect, but it's allowed us to get to where we are. And, tapping the equity markets for funding is one strategy. And of course, going down the venture capital route and attracting funding that way, they both have their sort of fors and againsts,
Like I said, it's just the story behind your company is so, it's so touching. Like you all have put your blood, sweat, and tears into this, try to make it work, whether through downturns and all these hurdles that you faced being in Australia, going through the 2005 recession, everything, you're still doing everything you can to make this work because you believe in the tech. And that is such a beautiful story. The last time we spoke, you said something very, very powerful to me, because it showed how you have a very realistic and grounded perspective running this business. You said if this technology isn't cost competitive, it's not going to take off. It is always going to be a niche industry. It's always going to be a gimmick, and it's not going to be successful in the long run. And making the Hadrian cost competitive to traditional bricklaying was very, very important to you.
Yes, absolutely. It's important to the building community. It's as simple as that. You know, they want to build better. They want to build safer. They want to generate less waste. You know, there's not a building company around that's not trying to do all those things right. But when you're dealing with the same sort of materials and the same sort of work methods and all those things, it's very hard to make any change that doesn't affect the cost of building that structure. This is a very important bit, because, you know, we can't, as we go down the pathway of making improvements in the construction industry, make it more expensive. It must become cheaper and faster and better. And, you know, I see a lot of different things, and I know you do too, being developed around the world. And there's a lot of, you know, sort of hype built into these different sort of methods and new construction machines and techniques that come in. And at the end of the day, we see very few of them actually reach, you know, their full market potential, you know, and it's because at the end of the day, if you can't meet the cost point expectations of the building community, they'll just keep doing what they're doing today. And you know, fair enough.
There's no incentive to change.
That's right. And so it's up to us, you know, the innovators, to not just come up with a different way of doing it, but come up with a way of making it better, cheaper, and faster than how we're doing it. And that's been our focus, you know. We decided a long time ago that, you know, we'd die at the wheel trying to achieve that, because we just didn't want to be another, you know, sort of hype company where it's like, you know, we're gonna change the world. We're gonna put roofs over everyone's heads, and we're gonna solve the world's, you know, housing shortage problems. You know, you won't hear us saying those things.
So is the Hadrian robot cost competitive to bricklaying in Australia?
Look, it is at the moment, but we know it can be so much more. Okay, so the machine you can see behind me in that image, you know, that lays bricks at around about, you know, 10 to 15 times faster than a human on an overall structure basis. Okay, not on necessarily a minute by minute basis, but, you know, we can produce a full house structure in, say, you know, a couple of days. 27 hours is about the average time of laying time. And we can compete with that, and we are competing with that in the Perth market now. But that was not the goal of those machines that we have at the moment. They were sort of dream makers, if you like. That was to prove that this is all possible, because no one even believed no one even believed that we could do this. No one thought that you could put a pallet of bricks in the back of a fully mobile robot and print a full house structure, 25 or 30 meters away, through a stabilized robotic boom, without a human hand having to touch a brick, right? Which was what we've done here. That was the goal of these machines. Now we know that all works. Now we know where the bottlenecks are. Now we know where we can make the real improvements. And now we know how we can make this sing from an economics perspective. There will be no other way. When we've done with this, there will be no other way of producing a load-bearing structure with any other type of material, with any other type of machine, anywhere, anyhow, other than using a machine like this. Right?
So the machine, So the machine itself doesn't pour mortar in between the courses, right? You lay the bricks and then you pour mortar in the voids, the cavities.
No, what we do, Belinda, we've introduced a construction adhesive system. So we use bricks that have been rectified top and bottom. So they're quite accurate in their height. Not so accurate in their length, which isn't as important to us, but they have to be quite accurate in their height. So we need quite a consistent geometry of the blocks themselves, or the bricks, right? So the cost of the bricks that we use are generally about 10% higher than a normal off-the-shelf brick, because it just needs to go through one more process in the plant, right? And then we use construction adhesive, which is 2 to 3 times stronger than standard wet mortars that bricklayers use. And because this is the non-cosmetic load-bearing structure, you don't see these walls, right? Inside walls are either plastered and drywalled and painted and hanging your pictures on there. And on the outside, you either have a rendered skin put on the outside, you might have a layer of insulation, rendered skin, or you might even have a face brick finish put on the outside of the house. So the structures that we build, like the one you see behind us, which is a cement block structure, we also build these with clay bricks and all other sorts of materials too. But we just eliminated the need to put wet mortar between the joints, because a robot doesn't need a leveling agent. So that the mortar joint really for a manual bricklayer is a way of leveling each brick as he goes along the wall. Okay, whereas with the robot, it will only lay a level brick. It doesn't need to go, I need to lift this one up or maybe put the next one down. It will only do it the way that it's been programmed to do. So providing you're starting with a good slab, reasonable quality slab, you just build course by course, layer by layer, and you just put them together with construction adhesive, which, has got hundreds of years worth of cycle testing proof that this stuff is not going anywhere in a hurry. It's very strong. It's safe. It's, most of the things that are in your home are already stuck together with pretty well the same material. The desk that's in front of you at the moment and the shelves behind you, they all use basically the same sort of construction adhesives. And we've just now incorporated that into the walls of the home. Obviously, we've had that certified for use. We've got our US certification process almost at the end, which will be a great outcome to not only be able to present robots to the US building community, but a fully registered and approved way. So that's the other thing that you've got to do, is not just come up with a technology. You've got to have it certified for use,
tested,
and it's got to go through all the rigors of testing and all those sorts of things. So to answer your question, we don't use wet mortars anymore. We've gone to modern construction adhesive.
But you do use some sort of reinforcement in the walls?
Not necessarily, only if the building code calls for it. So, a masonry block is around about, anywhere between 12 and 30 MPa. So it's a very strong piece of building material. We don't need to put pillars or reinforcement in the walls because it's already a load-bearing piece of building material.
Oh, wow.
So like if you go 2 stories, like the blocks behind me in that image there, you can go to 10 stories with those blocks without putting reinforcement in the walls. Gosh. Like that. Yeah, but if you go to, say in Florida, for instance, in certain areas in Australia where you have high wind loadings, the building code may call for reinforcement to put in some parts of the walls. And also that it might call for core filling with concrete in certain parts of the house structure too, just to give it that additional structural integrity. But if you're not in high wind load areas or volatile sort of, volcanic areas, you don't need to do anything like that. Basically just print the structure, put a roof on it and lock it up.
So does the robot also lay the construction adhesive that you were talking about, or is that done by, it does?
Yeah, so when the brick comes down through the boom, the last thing that happens to is that it goes over an application roller, and it gets the right dose of material put on each brick. And it does have to be dosed because it's a very strong material. So we actually have to engineer it downwards, not upwards. Like we don't put lots and lots of this stuff on to make it stronger, because walls actually do have to have some cracks in them from time to time, and you want the cracks to appear on the coursings of the bricks. You don't want it sort of cracking diagonally through the wall, because buildings do move, right? Doesn't matter whether it's built by a robot or built by hand, structures move.
Expand and contract,
for various reasons. So no, we don't need to put any of that in the walls.
So what has the reception to your new technology been like in Australia? Are builders still as old-fashioned as they are here in the States, or have they really been excited and they're willing to try it out?
Look, they have been conservative, and rightfully so. When someone sort of comes along with a new, way of doing things, they generally like to stand back and watch what happens.
You don't want to be the guinea pig.
Yeah. And again, rightfully so. But we've been really fortunate. We've had fantastic uptake in Perth, and timing wise, it was probably good for us because we did sort of enter the market, although 3 months after the beginning of a global pandemic. But that aside, that little wrinkle aside, it's also a very high building activity market at the moment in Australia. There was a lot of stimulus money went into the construction market, as it does generally anywhere around the world when you're sort of trying to fight off a recession and keep the economy stimulated. A lot of money gets put into attracting people to building new homes and keeping the construction market buoyant. Well, that's how it's been in Australia the last couple of years. So we've had a pretty buoyant market. There's been a lot of demand out there for bricklayers, and they've been hard to get and they've been expensive. So it's been quite easy for us to get the customers that we've needed, which is good because we've been able to prove our wares to our customers, show them what we can do, make improvements to our processes and procedures on the way through. We're the new guys in town, right? So we've got to fit into the way that they do things. We can't sort of present a new product and a new process and say, hey guys, you've got to change everything else if you want to use these robots. What we've done is we've ensured that we just come in and do the bricklaying bit. We don't have to change. We don't want to change anything else if we don't have to. That should still be a seamless process for the builders.
Shouldn't be disruptive to everyone else in every other subcontractor.
You've got to fit in. You just got to fit in. You can't be you can't sort of expect builders to change the entire way they build a house, okay, just to incorporate your breakthrough technology. And I know that there are some other stuff, there's some other tech developments going on around the world where the tech's fantastic, and I think some of the stuff that people have created is amazing, but it is going to require the construction industry and the
be completely disrupted. Yes.
That's going to be hard. That's a real barrier to entry for those folks, I'm afraid.
So like I said, you've taken such a grounded, realistic approach to this. You're not going to interfere in what other people are doing. You're going to fix this one thing, have people adopt this new solution, and then maybe you could start working with other trades in the industry. So how many projects have you completed in Australia over the past 2 years?
Look, if we talk house equivalents, because we've done a few large commercial jobs, and we've done some high density unit development jobs, it's probably only the equivalent of about 30 standard houses, 4-bedroom, 2-bathroom homes in terms of size and brick volume. But what we have done, and we've done this purposefully, is we've chosen the early jobs for the robots to be as varied in size and complexity as we possibly could, to really put not only the machines but also our people, our teams, through the rigors of proving out our ability to handle complex jobs. Like the one you can see behind me there is it's a 16-unit multi-story development, this one for Western Australia's largest property developer. And it's the first time we've ever built 2 stories with the machines. It's the first time we've done what we call retreat builds, because each of these units behind me is interconnected. They all have party walls. They have triple cavity walls. The triple cavity walls go up to 8 meters. And this is a very complex structure that we're building there. But the brilliant thing is we can do it. So it's not as though we say, look, as long as your structure is, no wider than 12 meters and no longer than 15 meters and no higher than 3 meters, we can do it. Give it to us, whatever you got. We can ask the machine to do it. We can generally get the machine in the right sort of position. Of course, we model all that out before we get to site. We know if the machine's capable of building something before we leave. We know exactly how many bricks are in the structure before we get there, and all those things. I mean, that's the beautiful thing about digital construction, and that's a really important term, because people are going to hear that a lot more in the future. It's just we're sort of moving away from the human hand as much as we can, and we're digitalizing everything now as much as possible. And some of the real manual, laborious trades, particularly like masonry and bricklaying, they're really hard jobs. The guys and girls that do that work seriously earn their money, right? And I admire not only the hard work that they do, but their workmanship too. The artisan work of a bricklayer, in my view, is just outstanding, and I love it. Always have.
I've watched some of those competitions. I think they're in Vegas, where they have this speed bricklaying, and they're machines. Those humans really look like machines because their wall is super clean, but they build it so fast.
Oh yeah, no, they're good.
Enough. Yeah.
The problem is, Belinda, there's not enough people coming out of schools or universities that want to do that. And the guys that you're talking about in Vegas, and I've been there and seen them too, they're amazing. Unfortunately, when they get to about 45 or 48 years of age, not only do they start to slow down, but they find it very hard to tie up their shoelaces.
It's taking a toll on their bodies.
Yeah, this is the thing, like we've got to let machines do the hard, heavy, horrible stuff, right? The dull, dirty, dangerous, those things, and let the masons do the work that I think really only a human hand can do. That real face brick finish on a house is stunning. And I can tell you that's going to be a damn hard thing to get a machine to do, in my view.
Why do you say that?
Because there's a coordination between the human hand and the human eye, and it has a way of looking at an area that they're going to cover with bricks, and they look at it from one end and go, okay, I'm going to put this brick here and that brick there, and this brick's a little bit darker in color, so I'm sort of going to put that one there. There's just some things that's going to be damn hard to replicate with a machine. But I think when you look at the amount of available bricklayers and masons around the world right now, and the way that the numbers are reducing every year due to people retiring at one end and not many people coming into the trade at the other end, the more we can get the machines to do on the heavy, hard and horrible, or the dull, dirty, dangerous, the more we can use the available bricklayers to do the work, that hand-eye coordinated work that I think only humans can do. And for them, in fairness too, I think that's, they get paid more money to do that than they do to lay the bricks like you see behind me. Yeah. All right. So they, the sort of the stuff that you never see in a structure, the non-cosmetic load-bearing bricks and blocks, let the machines do that. It's too hard and heavy for people. And let's use the skilled, qualified tradespeople that we've got to do the real artisan work, the stuff that we really like to see on a building. So
earlier you mentioned the software side of it, the digital construction side of it. So that's what, working in architecture firms, I was always very disappointed to see how much data was lost from a BIM model, from a 3D Revit model to construction drawings, because you have all this information you can extract, like square footage and even the volume of a space. And once you just print it onto sheets of paper, send that off to a job site, you've lost all that data. So your company has developed a proprietary software, sort of like a slicing software, where you all can calculate exactly how many bricks are going to be needed to be taken to the job site, and also how the bricks are going to be laid, the sequence of events.
That's right. I mean, look, you can't have a digital construction machine without having a software platform developed for it specifically. I mean, we've developed our software program, our bespoke one, so that it aligns nicely with platforms like Revit, because it's, I think, 75% of the world's designers and architects use Revit. So if you're not aligned again with what is being used on everyone's design table, they're not going to adopt you. So very quickly you can take a Revit design and run it through our architectural design platform that we've developed, and it does give you some really important data, and it does allow the build sequence to continue through on a single source of data. What happens when you reach the manual trades generally is it goes from a program on a laptop or a tablet to a piece of paper, where you see guys sort of walking around a building site, turning pieces of paper upside down, trying to work out which way's up. And then at some point in time, it turns back into a digital construction sequence, right? And this is the gap we've tried to close. Now, very quickly, we can take a design that is either come off a designer's table or from an architect, or perhaps even something you scribbled on the back of a napkin or a coaster at a bar. And we can very quickly turn that into a structure where we know a lot of things about that house structure that we will know for the next 150 years while it's up, you know. But importantly for us, we know exactly how much product is required to build a house to the brick. We know exactly how many bricks need to be cut, whether they be halves, quarters, or three-quarters. And importantly, we know exactly how much material we will discard to landfill before we've even started building the structure. And this is something that I've really tried to press home with our team over the last few years, is I feel that that's one of the most important things that we can contribute here, is try and reduce the amount of over ordering that goes on for building materials, particularly on the brick side. Okay. So much masonry waste goes to landfill, and it doesn't deteriorate well over time, as you can imagine. So, you know, once you've made a brick or a block, it's pretty well going to be like that for eternity. So we have to reduce the amount we are throwing out, which, you know, the benefits of that flow right up the chain, because if it means that you're throwing less out, it means you have to order less.
Yeah.
So someone somewhere is paying for less. Someone somewhere is making less, and therefore we're actually, you know, using less materials, and we're having less of an impact on the planet. You know, it's the benefits flow on. Let's use less, people. Let's throw as least as possible out. And, you know, we've just demonstrated in Perth with our Hadrian 1 machine, where we were able to build a full house structure without throwing a single brick to landfill. Okay, so we took exactly the right amount of material. We had pre-sequenced pallets delivered to site. There was, I think, 4 pallets had, you know, quarters and halves and three-quarter blocks stacked on them. And we put one of those pallets in the back of the machine, along with, you know, 3 or 4 pallets of standard size bricks. And the program that the machine was operating off had the machine picking exactly the right brick at exactly the right time. No saw, no cutting, no silica dust. And we printed that house out, and there was not a single brick left in the back of the machine when that last one went down. And that's a massive achievement.
Much cleaner job site too.
Totally. It's so much better in so many ways. And so, you know, if we can do that mainstream, if we can get, you know, the pre-sequenced pallets coming out of the brick factories that way and delivered to site ready to go through a robot, you can imagine the benefits that flow if we can get that to happen. And that's going to be one of my next challenges, is not only, you know, we automated the laying of brick, we've got to bring everybody on this journey, not, you know, the brick manufacturers and also the builders. You know, everyone's involved in sort of making a contribution toward this improvement process. You know, let's make less, let's use less. And let's discard less. Yeah, and all that. At the end of the day, someone somewhere is paying less for that house. Now, if I'm going to make any outlandish statements about improving the planet, Linda, from an affordability perspective, the only thing that we can do, really, I believe, is try and do things faster so that there's less labor cost involved, and use less materials. Okay, if we can do those two things, someone somewhere is paying less for that home. You know, and that really can, I think, be our only real true contribution to that.
So related to the effect that we have on our environment is the use of concrete. Now, the Hadrian, that's obviously a concern right now, is the carbon footprint of concrete, carbon footprint of CMU blocks. And there's a lot of innovation going on in that field, in the material sciences field, where people are coming out with new types of bricks. So you have actually future-proofed the Hadrian robot to use different sort of bricks in the future.
Indeed. Yeah, we can see that, you know, over time, there's going to be, you know, a lot of change in the way that building materials are developed, with a focus on, you know, improving the impact on the environment, of course. But, you know, as long as something looks like a brick, is shaped like a brick, regardless of what it's made of, whether it's made of, you know, exotic polymers, or green recyclables, or you know, waste from the world's oceans, whatever that may be, if it can be pressed into the shape of a brick, the machine you see behind me there will always be able to lay it. So, as we do see a shift away from, the more environmentally costly building materials like cement, I think anything that's being developed today for the construction industry and in other sectors needs to have a very clear focus on the fact that, probably 10 years from now, we're going to start to see a significant shift, I believe, away from some of those, more traditional materials towards some of the more environmentally friendly materials. And the speed of uptake there, again, will be due to the cost of these materials. It always is. Even though we all believe that, there's a better material that we could be using and, this stuff's so much nicer on the environment, I'm afraid to say that if it's not cost effective or cost equivalent, it's going to sit on the
Not going to
shelf.
be adopted. Yeah, you're very,
Mhm.
very right.
Yeah.
So all the lessons that you've learned building all these homes in Perth over the last 2 years, you've used it towards a new version of the Hadrian robot that is extremely exciting, in my opinion. It's going to be a modularized version.
Yeah. So, obviously you learn as you go and you do things that your budget allows you to do and your time frames allow you to do. The machine that we have under assembly at the moment, yes, it's a much bigger robot. It allows us to build all our home structures and buildings from the road edge. Doesn't need to come off the curb, or doesn't need to come up over the curb, if you like.
As you can see in that image behind you.
Yeah, that one's come up over the curb. It sits on the, if that ground was boggy, we'd have to put, bog mats under it and stuff like that to sort of stabilize it a bit. But the new machine will be what we call road ready or road verge capable, with a 32-meter boom, so another 8 meters of reach on the boom. And importantly, it's sort of broken down into, 9 or 10 particular modules, which over time can be improved individually. And it sort of allows us to stay on that path of continuous improvement without having to do a complete machine redesign.
So what you mean is that if it's composed of 10 parts and you've found a flaw or something that can be improved in one part, you don't have to redesign the entire machine. You can just swap that one part out and basically create the next version of the Hadrian robot.
Yeah, and even if it's not a problematic module, we might just see more room for improvement within that module, and we can develop that on the side. And then once it's ready for trial, take out the old module, put the new one in, and try and keep your evolution of the machine going whilst you are producing those machines. You don't want to have to stop and reiterate. Any reiteration of a machine design is a costly thing to do in terms of time and money. So you've got to try and limit the amount of time and money required to stay on that continuous improvement pathway. And modularizing your machinery is certainly one way of doing that. I mean, it's what the major machine manufacturers have been doing for years.
So your business model is not to necessarily sell these robots, but maybe to lease them to local builders in the market?
Yeah, look, I think it'll take on a couple of different shapes and sizes. There are certain markets around the world where machine ownership just makes so much more sense, and the appetite is much stronger toward machine ownership. But in your volume home market, probably in the United States and Australia and Europe, people don't want to have to buy and operate a robot to build a house. What they really want is they want that service on the end of a phone. All right. We call it wall on call. All right. And our business model predominantly is a wall as a service model. So to paint a bit of a visual picture on that, or a mental picture, if you picture, say, 10 of those machines behind me there, working, say, to the south side of Orlando, Florida, and maybe another 10 machines positioned on the north side of Orlando, Florida. And those machines have been booked, if you like, for the next 24 months to visit certain sites on certain days to build certain structures for customers. There's a couple of things that a machine allows you to do very nicely, and that is to accurately forecast the time arrival of machine, the departure of the machine, and therefore exactly what you can charge for that machine's time. It doesn't fluctuate. You can forecast that price of delivery of building that structure 2 years out, which is a real risk reducing factor for the building community, because they're constantly having to deal with the fluctuating prices of building materials, and they're constantly dealing with the fluctuating price of labor. What machines do is they stabilize those things. Okay, we don't need that. The price doesn't need to fluctuate. We know what the price of the machine is today. We know what it's going to be in 2 years' time. And then if the builders can book the machine's time, then they know that, all right, next year we're going to be building 1,000 homes with these machines, and those sort of the operator of that 10 machine outlet or franchise, if you like, they just got to keep the machines serviceable and get them out onto building sites every day and servicing the building community. So they get the benefits of the machinery and the automation. I think the home buyer gets the benefit of the cost reduction and the waste reduction and the safety improvements and everything like that. And for us, it means that we're producing lots of machines and we're putting them into multi-machine business units that are positioned strategically in different geographies, whether it be in cities or towns or whatever, to service the building needs of that particular area. And what happens that when the area gets built out or the building volume starts to diminish, the machines are mobile. You take them to somewhere where the building activity is stronger, and you just move them, keep moving them around. So there's a lot of benefits to them being mobile. I think the benefits to the building community are not necessarily to own the machines, but to be able to get wall on call when they need it. And I think the benefits really flow through the building community that way and with that model. So that's the one we're sort of focusing on very strongly at the moment.
So I have two really interesting questions from the community. One of them is, how do you account for unevenness on a job site? Because the way a slab is poured it's never perfect. We want it to be perfect, but there's going to be some unevenness. How do you account for that fault while laying these CMU bricks?
It's a really, really good question. That person's obviously thought about this a fair bit. Look, there's a couple of reasons why we get poor quality slabs. It can be poor equipment and lack of detail by the people that are doing it. Okay, so what we do with the sites that we go to is we tend to use the same guys, which they understand that we like to have our slabs done as accurately as possible. You can do anything that you want. It just generally costs you a bit more, right? So if you want nice, accurate slabs, they generally cost you about, $300 or $400 more to get that work done to the level of accuracy that we like. And that's around about 3 to 5 millimeters of variation over the house slab itself, okay? If we get 3 to 5 millimeters, that's around about 5 times better than the accuracy that a manual mason will give you over the same distance, right?
Oh, wow. Okay.
Generally, if you did a measurement corner to corner over a house structure after a manual mason team has been through, you can get up to 25 millimeters of difference in the height. Whereas whatever we have at the base, if we have 3 to 5 millimeters there, that's what you'll end up at the top. You just transfer it to the top, right? So we put a bit more emphasis on the slabs. If we do get any variation come through the wall anywhere, and you can see it, if the machine's going around, it's doing it course by course, and you go, oh, there's a bit of a bump appearing there. We have what we call a bridge block, and it's just a brick that's sort of got the bottom of it milled out a little bit, and we take out the brick there and we just plonk one of those bridge blocks in, and that makes it level again, and then the machine just keeps printing around. It's a real I suppose practical solution to that problem, and yes, for whoever that asked that, we do encounter that from time to time, but we have solutions for it.
Another fun question. I don't know if I would classify it as fun, but what's going to happen if your robot becomes sentient?
You're going to have to tell me what that actually means. I'm sorry.
Well, if the robot starts having a brain of its own and starts to starts laying bricks wherever it wants to lay bricks. And
it's not that unreasonable to think that at some point in time, these things are going to drive themselves to a building site. Okay, they just are. And there's going to be a trailer of building materials that's been delivered there, and it will see that, and it will back up to that trailer and connect to it. It will be able to feed itself, and it will be able to build that structure and depart. All this is going to happen, probably and hopefully not in my lifetime, but I think for the young kids coming through at the moment who see AI and robotics and all these technologies that are really starting to get traction now, it's gonna be that way for them. They're gonna see that, so.
But right now, you'll still drive the robot to the job site, and then after that, it takes over and runs itself.
Yeah. Once the machine knows where the slab is in space, so we basically take 3 or 4 surveys of the slab, and then that correlates with the program of that the machine's been emailed of the structure it's going to build. And once it knows where that slab sits in space, then it will just build that structure. Okay, no matter where it is, whether it's below ground level, whether it's above ground level. It really doesn't matter, as long as the machine understands where that sits, and then it knows where every single brick is in space on top of that slab. It doesn't lay a brick on top of another brick.
Yeah.
It lets a brick go in a point of space where that brick should reside, if that makes sense.
That's true.
Right?
Yes, that's very true.
Yeah. So that's not sort of saying like, where's the other brick I just laid? Oh, there it is. I'll put another one on top. If you just ask the machine to lay brick number 755, it will just let a brick go in space. Just let it go out in the open, because so that's where
it's similar to 3D concrete printing. I mean, this is also a form of 3D concrete printing, because you're relying on X, Y, and Z coordinates. You're not relying on what happens below, what happens above. Like you just said, it lays at this particular coordinate on the floor slab. That's
right. It's exactly the same. The only difference between us and the 3D concrete printing community is that we're using what we'd term as a QC product, a brick or a block. It's of a known dimension. Their additive material is wet concrete. Our additive material is a concrete clay or an AAC block. But similarly, they're all 3D printers. Most of the 3D printers we see around the world are like a gantry-based system, where they put the infrastructure in and then they pump the concrete to the nozzle through a gantry system. Whereas we've developed a highway capable mobile robot system to do the same thing. I think in the future, we may also do some 3D concrete printing using our mobile system too. That's all possible. But at the moment, there's over 2 trillion bricks and blocks laid around the world every year, and the humans needed to lay those bricks and blocks are, like I said, retiring at quite a high rate now, and there's a very little uptake of those trades from our 21st century school leavers, and that leaves a big void that can only be filled with machines.
Yeah.
And we don't see a lot of other people in the world doing what we're doing, and we think that's just because it's a damn hard thing to do. The enabling underlying tech that allows us to do what we do, it's very unique, and no one else has been able to develop it to the level of accuracy that we have, and therefore it's important that we try and make as much ground
yes.
As many inroads as we positive inroads as we possibly can while we have the space.
Yeah.
Excuse me, while we have the space to ourselves.
It's tough to be the first in the industry, because you have to learn all the hard lessons, and then next person learns it from you. But you are, like you said, you are I haven't seen any other real company that has made as much progress as you have laying concrete bricks, and it's really admirable. So what are your future plans for the company in the next 5 years? Are you going to come over to the States pretty soon?
Yes, we are. I mean, look, we had plans to sort of establish ourselves a bit of a beachhead or a footprint there, 2 years ago. And literally, I arrived back from the US about 10 days before the pandemic hit us, and all the plans that we had just had to get put on ice. We're starting to, reinvigorate those plans now. I will be in the US in the coming weeks. The market there and the appetite there for this sort of thing hasn't changed, that's for sure. It's just been our inability to get over there and sort of demonstrate what we can do. But we also have a lot of demand for this in the European market, in the clay block space, in the autoclaved aerated concrete space.
Yeah.
And then, of course, if you go to the GCC region, the Middle East, around the UAE and Saudi Arabia and Kuwait and Oman and those countries, it is massive, a
Yes.
massive opportunity there. And they need machines there more than anybody because they have much higher labor constraint problems than anyone else in the world there. They rely on 85% imported labor to build their cities and their towns and their homes. And that's becoming more and more expensive all the time. And building is just such a cost-driven exercise. And this really needs to be, sort of driven home to people who are thinking about developing something as a piece of construction equipment to improve things. It has to be cost effective, and then there's certain different markets for it that will pay different amounts for it depending upon its demand and its appetite and its need. Some places will pay twice as much for a robot to lay a brick than others. So you look around and you have to assess the best early entry markets for the machines. And before you get to that, you've got to work out how you're going to make lots of them and who you're going to do that with. Then you've got to do a lot of work in the background to understand what's the cost of that machine going to be coming out of a production line, what therefore will become that machine's daily cost. Therefore, how much do we have to charge per brick to make sure that someone or that everyone is extracting some benefit out of the machine. The operator of the machine has to make money. The builder using the machine has to be using it because he's going to save time or money or something else down the track. And there has to be benefit after benefit after benefit. And if there's a gap there, if there's a problem that needs to be overcome, whether it be a time or a setup or a cost problem, that's a real barrier to entry. Yeah.
I love really how thorough you are, how much you've thought of every aspect of this business. It seems like such a solid idea. And I'm excited to see the next version of your robot and excited to see this robot come to the States. And we don't have many CMU buildings here in Texas, but Florida definitely does. And I think some areas in Houston do too. But I'm really impressed with how solid your business is, and congratulations on that.
Thanks, Belinda. Well, we're hoping to, like I said, make some positive change, and that all the time and effort that we've put in as a team in our company does reap some rewards and benefits for people into the future. And I think as pioneers, they say you get arrows in the chest and often in the back, and because you're the one that has to go over the hill or over the prairie to sort of see what the environment's like, and you learn with every one of those arrows that you get that you've got another problem that you've got to solve.
But you're paving a path for everyone who comes to this.
Yeah, I guess so. I mean, I don't really think of it like that. I just see it as a challenge that's worth taking on, and it's a tough one. There's so many aspects to a project like this, from raising the money to do it, to communicating to an industry that is, reluctant to change for good reasons, and then taking on the challenge of getting them to adopt and use. And making your invention or your creation a piece of mainstream equipment, right? I've said this a couple of times before, but for me, I think success is driving down the road and there's a Hadrian robot building a house or something and people don't even look twice at it. That's a win, right? That's a win right there. When you no longer are different, when you just become the mainstream.
The norm. It's not a gimmick, it's the norm.
Yeah. That's right. Yeah. And that's what I'm endeavoring to do.
I'm looking forward to that day, Mike. Thank you. Thank you so much for sharing all that information with us. If people want to learn more about the Hadrian robot, what's the best way to reach out to y'all?
Oh, look, we've got a lot of information on our website, www.fbr.com.au. We've got some great content. We've got our own content creation team internally. We film everything we do, and we probably talk a bit too much about ourselves, but, our team's pretty proud of what we're doing, and we know we're the only ones in the world doing it. And, we often do things for the very first time in the world, like world firsts, and we do them that often that we go, is that the first time in the world that that's ever been done? And we go, yep, I think it is. Okay. And people just move on now, but back in the earlier days, it was a real thing for the team to actually, kick another world first off, but it happens so often now, it's just become sort of like an every other day occurrence. So I'm really proud of what we've done, and proud of the people that are working with us, and we'll continue on, trying to, I suppose, make our little change in the industry, and appreciate people like yourself and platforms that you have, allowing people like me to sort of communicate that as best we can.
Well, thank you, Mike, again. And I'll provide links to your website, your Instagram page in the description.
Thanks, Belinda. Nice being with you today.